We're doing Chapter 2 review number 10, and if you were with us last time, we did 10 Part A. Now we're going to continue with 10 Part B. If you notice from the last time, I moved the answer to Part A down a little bit so we have a little more square room here for Part B. But for Part B, it asks us, what is the maximum reaction time we could have before hitting the brakes and avoid hitting the car? So what that means is that we have, let's just do a small graph right here. That means we're going to have initial velocity of 15 meters per second. Sorry, I wrote that below right there. And then when we see this ball roll out in front of us, we're going to do nothing for a short amount of time. That's your reaction time, right? That's when something happens, you react to it a fraction of a second later, hopefully. And then after that amount of reaction time, I'll call that RT, then you slam on the brakes and hopefully stop just in time to avoid hitting the car. So we have two parts right here. I'm going to call this part 1, and the reaction time is going to be our part 2. So in part 1, and I'm going to make different sections right here. I'm going to put part 1 and part 2. Part 1, our acceleration, that's negative 4.5 meters per second squared. Our initial velocity, VI, is equal to 15 meters per second. Our final velocity here is going to be V0 is going to be 0. Why did I say 0? VF, sorry. Our VF, our final velocity in part 1 here, is going to be 0 meters per second. All right, because we're decelerating down to 0. Give me a second. This is 15 meters per second up here. What else do we know about part 1? We know the acceleration. We also know the displacement. That is the amount of distance that is taken up to come to a stop. So delta x, I'll call it B for braking. We figured that out in part A. That's 25 meters. Okay, and we don't know our time. Our time for braking is still unknown. All right, well, part 2 is really what we want to find information about. Part 2, that's the reaction time part where you're not braking at all. We do know some information about that too. Our initial velocity, VI, is going to be 15 meters per second. Our final velocity, VF, is also going to be 15 meters per second. If the velocity doesn't change, it means that the acceleration is equal to 0 meters per second squared. Now, do we know the displacement for part 2? Well, we know that for the whole time between, that is the whole amount of time of you expending your reaction time and then the braking time, that distance that you have that time to spend to brake is 55 meters. So if we found out that part 1 is 25 meters, then that must mean that our reaction time displacement or distance is going to be 30 meters. So delta x RT, I'll call it that, is equal to 30 meters. So from the initial velocity, final velocity, acceleration, and time, are we able to find, acceleration and displacement, are we able to find time, our time 2, which is really our reaction time? And the answer is yes, we should be able to do that. Let's find an equation where we can solve for time using all of what we're told right here. In fact, we don't even need to use all of it. How about equation number 4? I'm going to move it down here below. We're told in equation number 4 of our 5 derived equations that our displacement, come on now, our reaction time displacement, that is going to be initial velocity times time, or reaction time, plus 1/2 times the acceleration times the time, or the reaction time, squared. So let's clean this up a little bit. Our reaction time displacement. Oh, we're not solving for that, are we? We know we're solving for t. So we're solving for t. Well, it's got a t squared here and then a regular t here. This looks an awful lot like a quadratic, and it certainly is. So let's move the x over and set the left side equal to 0. 0 equals, and I'll write it in the ax squared plus bx plus c format. That should be equals 1/2 times acceleration times t squared plus vi times initial velocity times t minus, because we're subtracting the x, minus x from both sides equals 0. Let's put in values for acceleration and for velocity and displacement, and then we'll have our a, b, and c values, which we can use with the quadratic formula. 1/2 times acceleration. Well, that equals 0. Well, that's easy. T squared plus, it's our initial velocity, that's 15 meters per second times time minus our displacement for part 2, that's 30. So it turns out that since we have no acceleration, the whole first part of the quadratic drops out, and we don't even have a quadratic anymore anyway. So we have 15 times t equals 30 meters. Sorry. Well, if we solve for t2 or t reaction time, that is, that should be reaction time, RT is going to be equal to 30 meters over 15 meters per second, which gives us an answer in seconds of 2 seconds. So our reaction time is equal to 2 seconds.